Myself, Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is Syntax Directed Definition, also called as SDD. Another topic is Types of SDD. SDD, Syntax Directed Definition, is a combination of contextual grammar and semantic rules. CFG plus semantic rules is called Syntax Directed Definition. SDD is a contextual grammar together with the semantic rules. In attribute grammar, attributes are associated with the grammar symbols of each production, which are evaluated by semantic rules associated with the production rules. See, in grammar with attributes is called attribute grammar. Each grammar symbol is associated with the attribute value. That value is evaluated by using semantic rules. For each production rule, a semantic rule is associated in the grammar, in the SDD. Suppose if X is a symbol and A is one of its attributes, then X dot A denotes the value at node X in the parse tree. In the parse tree, if there is a node labeled with X, X dot A denotes the value at node X. In translation scheme, the semantic rules are embedded with the right side of the production. See, in this example, E derives E plus T. The semantic rule associated for this production rule is E dot val is equals to E dot val plus T dot val. Here val is representing attribute value. This val is attribute value of symbol T. This val is attribute value for symbol E. Here this val is attribute value for symbol E. Another rule, E derives T, that is E dot val is equals to T dot val. Here attributes may be numbers, strings, references, that is addresses, and data types, etc. Types of attributes. We have two types of attributes, synthesized attribute and inherited attribute. First one, synthesized attribute. If a node takes a value from its children, then it is synthesized attribute. For example, A derives B, C, D. Here A is a parent, B, C, D are the children. B, C, D. A, B, C, D are the symbols of the grammar, but A is the parent and B, C and D are the children. Here node A will take value from its children, that is B, C, D. Then it is called synthesized attribute, that is A dot S. A dot S is B dot S. Here S is a synthesized attribute. S is an attribute. S is an attribute, synthesized attribute. Why it is synthesized means B is the children of the node, A is the parent. So that A is taking value from B. And also A dot S is equals to C dot S. C is the children, A is the parent. So that we are getting value from children. Like that, A dot S is D dot S. S is the synthesized attribute. Next, inherited attribute. If a node takes value from its parents or siblings, then it is called inherited value. For example, A derives B, C, D is the rule. Here A is the parent node, B, C and D are the children. Here C dot I is inherited attribute because C dot I is A dot I. A is the parent, C is the children. So from parent we are getting attribute value, so that it is inherited attribute. Like that, C dot I is equals to B dot I. Here C and B are siblings. C and B are siblings. C is getting value from left sibling, B is the left sibling. Then C dot I is equals to D dot I. D is the right sibling. C is getting value from right sibling. I indicates attribute value because here a node getting value from either a parent or siblings. That attribute value is inherited attribute. Then types of SDD. First one, S attributed SDD, also called as S attributed definition, also called as S attributed grammar. Then L attributed SDD, L attributed definition, also called as L attribute grammar. Basically, we have two types of SDD, that is S attributed SDD, L attributed SDD. What is S attributed SDD? SDD, if a SDD that uses only synthesized attributes is called S attributed SDD. In this example, first example, here this is the A is the parent, B is the children. So here synthesized attribute. In this all values, the attribute values are evaluated from its children. So that it is synthesized attribute. SDD that uses only synthesized attributes is called as S attributed SDD. What is L attributed SDD? SDD that uses both synthesized and inherited attributes is called L attributed SDD, but each inherited attribute is restricted to inherit from parents or left sibling. See, A derives B, C, D is the rule, production rule. Here B dot, for example, C dot I is equals to A dot I. It is L attributed SDD because attribute value of C is evaluated from taking the value of parent. Also C dot I is equals to B dot I. Here B is the left sibling of C, so that C is getting value from left sibling. These two are valid. Then C dot I is equals to D dot I. D is the right sibling. So here C is getting value from right sibling, so that it is not L attributed SDD. SDD that uses both synthesized and inherited attributes, but it is there is a restriction to get the attribute value from parents or only left siblings. Then second point, semantic actions are always placed at right end of the production is also called as postfix SDD. In S attributed SDD, the semantic rule here in the first slide, here the semantic rule is placed at the right side of the production. In L attributed SDD, semantic actions or semantic rules are placed anywhere in the RHS. For example, A derives B, C, D. In L attributed SDD, you can place semantic actions anywhere in the RHS. RHS is B, C, D. After B, you can place a semantic rule after the C, D. Or A derives B, C. After B, C, you can place a semantic action followed by D. Or A derives B, C, D semantic action. In L attributed SDD, the semantic actions are placed anywhere in the RHS. The last point, attributes are evaluated with bottom up parsing. Here S attributed in S attributed SDD, the attributes are evaluated by bottom up parsing method. That is, if you take a parse tree, we have to evaluate the attribute values of the nodes from leaves to top root node. Then attributes are evaluated by traversing parse tree depth first and left to right order. Here in L attributed SDD, the attributes are evaluated by using depth first traversal and left to right order of the parse tree.